This next problem set from this SAT math test prep book is on polygons. So let's begin right away. I would recommend you try the problems first after they appear on screen by pausing the video, trying it, and then coming back to see how I solve it. All right, what does this first one say? If the perimeter of the rectangle below is 56, what is the value of the base? Hopefully you tried it. What's the solution? Well, the concept this is testing is perimeter is the sum of the lengths of each side. So this side plus this side plus this side plus this side. So for a rectangle, it's 2 times the length plus 2 times the width, or 2 times the base plus 2 times the height. Okay? The base is unknown. The height we know is 10. We can plug it into the formula and solve for the base. 2b plus 2h is 56. Solve for b. B is 18. Okay? We can already eliminate choice E right away because it doesn't make sense that the base is the same as the perimeter. Okay? And similarly, if we know the concept of perimeter is sum of all the lanes, well, if the base is 40, you have another 40 up here. That's 80, which exceeds that as well. So you can easily eliminate choices as well if we understand the concept. Question 2. What is the perimeter of a square with area 49? Okay, this one's hopefully easy. Perimeter is sum of all the lengths of the sides. So in a square, there are 4 sides, okay, of equal length. We need to find the side. All right, that's what we need to answer this question. It's asking for perimeter. Now we're going to use this other piece of information. Area is 49. What's the area of a square? Well, the area of any parallelogram is base times height. Square is a special case of parallelogram. Okay? It's a special case because, first of all, it's a rhombus because all the lengths are the same. Okay? And then it's also a rectangle because the interior angles are 90 degrees. Okay, I didn't write all that here, but if we use this 49, it's equal to the base times the height. That's the formula for area of a parallelogram. So, or a rectangle is square. Okay. And as I just said, for a square, all the lengths are equal lengths. So B is equal to H. That's concept 3. So 49 is equal to B squared. B is equal to 7. But don't fall for the trap. Don't circle B. We got to answer the question. What's the perimeter? So it's 4 times 7, which is 28. The answer is D. Don't fall for the trap. It's the classic trap. Number 3, what is the area of the rectangle below? Okay, so area is base times height for rectangles. Do we have the base? Do we have the height? We don't. This is the base. This is the height. We got to find them. This angle over here is 90 degrees. That's just by definition for a rectangle. Okay? And since they give us that this is 60 degrees up here, this is a 30, 60, 90 right triangle. Okay? Which we know how to get the sides of easily if we're given any one of the sides. We're given the hypotenuse in this case, which is diagonal of the triangle, by the way. It's 20. So the angle opposite to the 30 degree over here, the height would be 10. And the base is 10 times root 3. So 10 times 10 root 3, 100 root 3 choice E. That's what I wrote over here. Okay. Question 4. What is the value of x in the parallelogram below? Okay. Parallelograms, any two adjacent angles are supplementary. Okay, so these two are supplementary, these two are supplementary, these two are supplementary, these two are supplementary. Okay, so x plus 40 equals 180, meaning x is 140. Number 5, what is the value of x in the parallelogram below? Okay, the concept here is these two angles, these opposite angles are congruent. So set them equal to each other. 15x minus 7 equals 13x plus 9. Solve for x. You got x is equal to 8. Pretty simple. Number 6, the area of the rectangle below is 40. What is the perimeter? Okay, so we want perimeter, so we want the sum of all the lanes. We need to find out what x is in order to get the lanes. Okay? And we use this first sentence to help us out. The area of a rectangle is base times height. So base, x plus 6 times height, x plus 3 is equal to 40. It's a quadratic we can solve, and we can solve by factoring in this case. So I won't go through all the steps there, but we get two solutions. X is negative 11, or x is 2. Well, x cannot be negative 11 because we'll have negative lengths then, okay? So we only choose x as 2. And we got to answer the question. We're interested in the perimeter. So this length is 2 plus 3, which is 5. This length is 6 plus 2, which is 8. So 2 times 5 plus 2 times 8, that is 26. That's the answer we fill in. Number 7, what is the area of the square below? Okay, so the question right away is, well, we need to find what x is in order to get the length of the sides. In this case, since it's a square, which is a rhombus, all the sides are equal in length. So 4x minus 3 equals 2x plus 5. X is equal to 4. If we solve that out, don't fill that in. That's not the answer. We're interested in the area of the square below. So if we get the length of any of the sides, they're all the same, right? So let's plug x is equal to 4 into, I don't know, this one. So that would be 13. Yeah, 13 squared is 169. That's the answer. Question 8. If the area of the rectangle is 120, what is the area of triangle CPD? Okay, this one's actually really easy if we understand some concepts. The area of a rectangle is the base times the height. Okay? Area of a triangle is half the base times the height. The triangle has the same base as the rectangle, yeah? And the triangle's height, if we draw a straight line down from P down to the segment CD, look, the height of the triangle is the same as the height of the rectangle. So, again, triangle's half the base times the height. Rectangle is base times height, the areas. So, the base and the height are the same for both shapes. So we just half the area of the rectangle. So answer is A, 60. As simple as that. All right. Number 9. In the parallelogram below, if x is 4 times as big as y, then x minus y equals what? We used this concept not long ago. We know that x and y are supplementary. So x plus y equals 180. And then we can make a substitution. X is 4 times as big as y, so x equals 4y. Okay. Ooh, I don't know why this is so big. This should be over here. Let me fix it now. I'm sure something will pop up. Oh, no? Okay, good. Oh, no, it does. Yeah. Okay, that's fine. This is good enough for now. Okay. So that's what I was saying here. So we substitute. So x is 4y, so we can plug in 4y as x. So 5y is 180. Y is 36 then. And as a result, x is 4 times 36, which is 144. Okay, look, two trap answers. Don't pick them. We're interested in x minus y. So 144 minus 36 is 108, choice B. This is filled with traps here, so be careful. Number 10, what is the area of the parallelogram below? You got to be careful for this one. This is a parallelogram, it doesn't say it's a rectangle. And we know it's not a rectangle because this angle is 60 degrees. A rectangle, it needs to be 90 degrees inside, everywhere. Okay? So the area is not just 20 times 40. Okay? Which they don't even have 800, so we're good. But don't be tempted to pick 80 because that looks really close. Okay, 20 is not the height. That's the whole point I'm trying to make. Don't fall for that trap. Instead, we can draw a line from this vertex down to this segment, the base. Okay, that would be the height of the parallelogram. And we would form a triangle over there. So let me go to the next slide. It's a 30, 60, 90 triangle, which we know the relationship of between the sides, how to get from one side to another. The hypotenuse is 20. So the side opposite to 30 degrees is 20 over 2, which is 10. And then 10 root 3 is the height as a result. Okay, so base 40 times height, which is 10 root 3. 400 root 3 is the answer. Okay, again, don't fall for the trap that you found the height to be 10 root 3 and you pick C. Okay, it's very common for these multi-step geometry problems. They pick an intermediary value, or pick as one of the choices. And if you fall for the trap, you're done for. Question 11. The base of a rectangle is 3 times as long as the height. If the perimeter is 64, what is the area of the rectangle? We're interested in area, which is base times height, okay? And we know what the perimeter is for rectangles is 2 times the base plus 2 times the height. Okay, and then they give us, in the first sentence, base is 3 times as long as the height. So B is equal to 3H. We can put all the pieces of the puzzle together to solve this question, okay? So, as I was saying, perimeter is 64, which is 2 times the base plus 2 times the height. And then in the first sentence, they gave us B is equal to 3H. We can make a substitution. B as 3H. Solve for H. H is 8. And then we can get B. B is 3H. So 3 times 8, which is 24. Don't fall for the trap. See? This is why I show my work clearly so that you can see these traps come up often. Okay? We got to answer the question. They're asking for area. So area is base times height. So 8 times 24, 192. This is a poorly written question. Let's see if you can catch it. What is the value of x in the figure seen below? Okay. The reason I say this is written poorly is because it makes certain assumptions that we cannot, in general, make. Okay? If you're a very average student, you'll make these assumptions versus a high-performing student, arguably some more honors students, possibly, not always the case. Some honors students are very mediocre, from my experience. Just comes with the fact that they just get placed in the wrong class, or yeah, they're just put in the wrong class due to whatever reason. If you ever took honors geometry, you probably had to be really rigorous in proofs. And if you have that background, this should help you spot why this is a poorly written question. If you're not able to spot it and you make certain assumptions, you'll get it wrong in a typical honors geometry class. But anyway, why is this a poorly written question? It didn't say that this line segment of 10 and this line segment of 6 are parallel, and this line segment of 10 down here and this line segment of 6 up here are parallel. It doesn't say that. Okay? And it doesn't say that these angles are 90 degrees. We can't make that assumption on the SAT. Okay? The SAT, this is a third-party test prep book, so they're not as good at writing questions. The SAT is typically more precise, and they say things like not drawn to scale or something like that sometimes, if I remember correctly. But we can't make those assumptions, okay? So to solve this problem, we are going to make those assumptions. But in general, we cannot if it doesn't tell you explicitly. Okay? And we couldn't even prove that these are 90 degrees. There's no way. Okay? So moving on with these assumptions now. We can break the figure up into smaller shapes to help us out. Okay? This is when these assumptions work. I mean, these assumptions make the problem a lot easier. And in this publisher's point of view, solvable. Okay. So if we assume this shape over here is a rectangle, well, this segment down here from this point up to this point is 6 as well. If we assume it's a rectangle, we can't assume it, but we're making an assumption now. Okay. Hopefully you see we're not given enough information to make that assumption, but we're going to just assume it now to solve this problem. Okay. So this segment is length 6. Okay. If this is 6, then this remaining segment is 4. Okay. And how does that help us? Well, what did I say again? Whoops. Yeah, okay. So this segment is 4. That might help us. Okay. And then similarly, this segment C over here, well, we can use segment addition again because this much is 6 from this piece of information over here. Again, we're assuming they're parallel. And this piece would be 10 minus 6, which is 4. So this piece is 4 as well. Now, how does that help us? Well, look, this is 4, this is 4. If we assume this is a right triangle by the fact that by the assumption that these were right angles, then this would work, okay? Then this would just be, you can use the Pythagorean theorem or 45, 45, 90 triangle. If we know that this is a right angle, it's for sure a 45, 45, 90 triangle because these two legs are congruent, okay? So x would be 4 root 2. Okay. Again, if you didn't get this problem, I wouldn't worry too much about it, to be honest, because it's a poorly written question. But if you're an honors student, hopefully you understood where the lack of information was, and you have to be careful. Okay? What is the area of a regular hexagon with perimeter 24? There's lots of ways that we can go about this. Here's how I showed my work. Okay, so first of all, we need to know what a regular polygon is. It just means that all sides are equal length. Okay, how many sides does the hexagon have? 6 sides. And then we need to know that perimeter is the sum of the length of each side. So if there are 6 sides of all equal length, and the perimeter is 24, so it should be a 24. I don't know why. 6 there. 24 is equal to 6 times the length of one side. So one side is length of 4. Okay? We're like a third of the way through. We also know that the central angle is 60 degrees. This is the central angle. So if you take the center of the regular polygon, you draw a radius from the center to one of the vertices and do it repeat for every other vertex. Okay, you will get angles. These would be called central angle. And how do we derive it? Well, a full circle is 360 degrees. 360 divided by the number of angles, which is the number of sides. That's 60 degrees, okay? So we're going to draw a representative triangle like this, all right? And then we use the isosceles triangle theorem. This comes up a lot, where if we draw the height of this isosceles triangle, would bisect the central angle. It was 6 degrees, right? So it splits up into two 30-degree angles. Also bisects this edge over here, which is the side of the hexagon. It's a length of 4, so it splits up into two tubes. Okay? Now there's a 30, 60, 90 triangle, so we can get that the height is 2 root 3, because this length is 2, it's opposite to a 30-degree, so the length opposite to the 60-degree, which is the height of the triangle, is 2 root 3, okay? So we can find the area of one triangle, and then there's 6 triangles in this hexagon, so we can just multiply by 6. And so the area of one triangle is half the base, which is half times 4. Or you could just take this half directly there. 2 times the height, which is 2 root 3. So 4 root 3 is one triangle. There's 6 of them. So 6 times 4 root 3, 24 root 3. Okay? That's the answer. An alternative way is, if you remember this formula, if you learned this, for regular polygons, you can do half the perimeter times the length of the apothem. What is the apothem? Well, don't get confused. Remember, this is a radius from the center to the vertex. The apothem is from the center to the center of one of the edges. So it'll be the height of the triangle, so 2 root 3. Okay, so, and the perimeter they gave us as 24. So 24 times half times 2 root 3, same answer, 24 root 3. You can pick your poison for which way you like better. 14, the angles of a pentagon are in ratio 9 to 10 to 12 to 14 to 15. What is the sum of the measures of the smallest and largest angles? Be careful not to fall for any traps. If there are any here, I don't remember. Be careful. So we need to know what ratio is, and we need to know what pentagon is, and we need to know the sum of the angles, interior angles inside a polygon. So a pentagon has 5 sides. So what's the measure? What's the sum of all the interior angles? Well, there's a general formula for any polygon. It's n minus 2 times 180 degrees, where n is the number of sides. So 3 times 180 is 540 degrees. Okay. Now we need to know that ratio is relative. So this is the, I don't want to use the word ratio again, because this is not how you define something. So for every 9 of the first atom, you have 10 of the second atom. For every 9 of the first atom, you have 12 of the 13th, sorry, of the third atom. Okay, and every 10 of the second atom, you have 12 of the third atom, so on and so forth. Okay, so we can represent it as, notice how I said it, 9 of the first, 10 of the second. Remember how we translate of, which operation is it? It's times. So we can just do it all relatively. 9x plus 10x plus 12x plus 14x plus 15x equals the 540 total. Okay, so if we solve for x is 9. Now we got to answer the question. It's asking for the sum of the measures of the smallest and largest angles. The smallest angle would be 9x, so 81. The largest would be 15 times 9, which is 135. Sum them up, you get 216. All right. Here's another poorly written question. What is the area of the figure seen below? Can you spot what makes this unsolvable? What assumptions we might have to make this solvable? It's very similar to the assumptions to the other problem. We have to assume these are right angles. Okay. And then, yeah, basically we're assuming that these are actually vertical and these are actually horizontal. And this is also vertical, okay? We have to make those assumptions. Okay, let's assume that and let's move on. We can, again, break up the shape into different pieces and then add the areas together. Okay, so let's focus on area 1 first. Area of a rectangle is base times the height, okay? Base, height, right there. So area 1 is 5 times 4, 20 degrees. Let's move on to area 2. Well, we have 4 plus 3 as the base, which is 7. Now what about the height? It would be 12 minus 5, which is 7. So this would be 7. Okay? So area 2 is 7 times 7, which is 49. So look, this should put a disclaimer also, not drawn to scale. This is actually a square. Doesn't look like it though, at least to me. Now let's move on to area 3. Well, we found the base was 7. And what's this height? Again, we just used segment addition. We found that this was 7, right? So 15 minus 7, this much left up here is 8. Okay, so half times 8 times 7, that's 28. We can add all 3 together now. Answer is 97. Okay, so notice how this was a very bad question. Okay, here's another one, poorly written. Which of the following expression represents the area of the shaded region below? Can you spot again why it's poorly written question? We assume that these are right angles. again. Okay, if they're not all right angles, this actually makes this problem not solvable at all. So we will assume, based on appearance, that these are perpendicular, okay? So you want the area of the shaded region below. So you can solve this in multiple ways. You can find the area of the big quadrilateral minus the area of the smaller quadrilateral. That's one way. You can find the area of all these triangles individually and add them up. That's another way. And that's probably the better way to do it, in my opinion, because, well, what did I say in the slide? So notice that all the sides of this outer quadrilateral, I can't say that word, quadrilateral, are the same length. They're all x plus y. It's not square. It's a rhombus. Rhombuses have sides of equal length. Squares do as well, but squares have another restriction that rhombuses do not. In that squares, the interior angles are right angles. Rhombuses, not always. Okay? Okay. So that's why we have to make that big assumption that these are right angles. If they are, then we can use the Pythagorean theorem, okay? Because actually, we don't even need the Pythagorean theorem, sorry, because these are all triangles of the same dimensions. They both have a leg x. They both have another leg y, okay? So we can just find the area of one of the triangles times 4. That's our answer, okay? So half the base, which is y, times the height, which is x. Okay, that's down here. That's equal to 2xy. Okay, again, only because we made that assumption, this problem is actually really easy. If we cannot make that assumption that these are right angles, then this problem is unsolvable. Let me double check also that I said that rhombuses don't have interior angles that are right angles. Let me double check that's correct. Yeah, my statement was correct. Good. Okay, so you got to be careful. Oh, and that's it. I'm at the end of this slide deck. Okay. Hopefully this was helpful in spite of some poorly written questions. My point is be very careful when you're solving geometry questions. You can't make certain assumptions. Okay. And the SAT, they should be better about marking like at least one right angle or a couple, or say things are parallel or whatnot. This test prep book did not do a good job. All right, hopefully you got something out of this video though, and hopefully I'll see you in the next video as well. Bye.